big deal. Generation, that's been around for a while now, but the uncertainty still remains. Customer behavior and customer expectations are changing drastically. And finally, assets. Our assets are aging. Are we keeping track of them? Do we have a good record? These are all questions that introduce, or these are factors that introduce tremendous unpredictability. Large backlogs mean outdated models. No matter how big the utility is, or how small it is, you're bound by the resources you have. Lacking context, this gives you suboptimal decisions, and context, is just anything that could impact the grid that utility maybe has control over or doesn't have control over. How do those impact those outside factors, or even internally if you have silos across your utility? And grid complexities, physics-based simulation may not be adequate only by itself, right? What else can we do to make that better, to actually manage these complexities and underutilize the big data? These are missed opportunities for O&M and capital expense reduction and metric optimization. And on the right side, on the left side there, you have the factors are summarized into socioeconomic, industrial loads, climate, cyber physical security, and EVs. These are some major ones. I think that today, the tools are not really adept to handle these five here. So in terms of the definition, we went extensively into this, but this is just a summary here. It's a high fidelity virtual and visual representation of a system of systems representing the electric grid, its surroundings, and any relevant context. That's the main portion here. And you can think of a system, could be a capacitor bank, a feeder, a substation, or the entire grid. So, at the end of the day, it's based on your use case. Digital twin can be real time or offline. And the objective here is to analyze the current state of the grid and predict the future state of the grid. And using the context and everything around the grid, that's how you come to those conclusions. And on the right side is one way to think about the digital twin and understand evaluating each utility, evaluating where they are in the process. And so you can imagine 5 levels, and across on the horizontal axis you have model, data, connection, uniqueness, and simulation. And so every utility can gauge where they are across these five categories. And I think that the important thing here is, there's more ways to describe this exact same picture here I showed, but I think that the general sense that should always be considered, which is what's your maturity across various categories. Now, ever since we wrote this paper, been doing a lot of talking with peers across the industry and everything, and we kind of decided, there's this idea of a digital twin 2.0. And really, why 2.0? Because we have been using digital twins for a long time. I think that's the biggest realization is just, let's just say it, right? Let's just, that way we kind of we integrate the thoughts of all these other people that are saying we already have a digital twin. Yes, you do. But digital twin 2.0 is different because it represents the next evolution, and it integrates some key pieces maybe that today don't exist, which is advanced intelligence that integrates AI, autonomy to eventually reach self-optimizing and decision support, dynamic interoperability, which is really seamless integration with diverse systems and data sources, and scalability, this idea of modularity, being cloud-based architectures for widespread deployment. And so these features here are only relevant because of the last few years, 5 years, maybe 7 years, where AI and the idea of autonomous grids and everything is becoming more prevalent. AI has been existing for a long time. However, those last 5 to 7 years, I think it's come to the utilities, and actually we now have it's gotten our attention. So because of that, I think it's the perfect time to move on to that digital twin 2.0, which is more cohesive. And why digital twin 2.0? it's increasing because of the increasing grid complexity. Managing high penetration of DERs, EVs, and inverter-based resources cannot be done with static assumptions or these static tools we have today. Aging infrastructure, uh, traditional manufacturer data sheets, and extrapolation techniques for asset maintenance may not be enough. Anomalies becoming the norm. Anomalies are difficult to track and learn from when they increase in frequency, right? So when they increase in frequency, now they're becoming the norm. However, at what point how do we keep up with all these anomalies, right? And we're seeing them even in my utility, and we're trying to keep up with them. However, today it's more of a manual effort. It's just machine learning where you're constantly updating your models, you're constantly having to retrain your model, and and if your resources are limited, how do you keep up with that? Data overload. Big data is becoming too cumbersome to analyze through queries. Insights are limited because of that. And finally, low fidelity simulation. How accurate are the models and predictions compared to reality? I think that's a big question. I feel like we don't have time to ask sometimes because we're so bogged down by the day-to-day work. And so this all kind of got us to think about what does this digital to immaturity look like. It's kind of relating to the initial picture I showed you, which is the 5 dimensions. But you can break it down into a descriptive twin, which is a live editable version of grid design and construction data. Informative twin, which is integrating sensors and other live data into the model to gain more context. Predictive twin, which leverages data for insights and predicting future events. Comprehensive twin, which simulates future scenarios and considers what if questions, but more comprehensively, meaning across various systems. And then autonomous twin, which is self-sustaining, assists with decision making by informing stakeholders on whether it's business, engineering, or operations in real time. And so the autonomous twin is the end goal. I feel like um, we are somewhere, when I say we as an industry are somewhere between predictive and comprehensive, right? Not everybody, but just talking about if you have an IoT stack and you have some level of maturity there with in terms of collecting data, I think the predictive comprehensive twin is really where we reside. But that transition right into fully comprehensive and into autonomous, that is the biggest hurdle, I feel like. So what are some fundamental digital twin 2.0 components? Model maintenance, which is automating real-time updates of dynamic grid models. Interactive visualization, whether it's 3D or just context-rich representation for better decision making. Simulation engine, multi-domain simulations. AI integration, predictive insights, and autonomous recommendations. Data management, unifying and doing quality check on multimodal data sets, and cybersecurity, which is protecting your CEII data. So I think these are all fundamental because each one of them enables you to get this holistic and to reach autonomy, because autonomy without clean data is not autonomous, right? A simulation engine without having a strong one, you're not going to have this idea of a comprehensive view. um, in terms of architecture, we have some basic, not requirements, but just basic things to consider, which is being an open platform, vendor agnostic. It could be you can say interoperable, but the idea here is, can we, because not a single, what I've been saying here is not one single vendor can do it all, or should claim to be able to do it all, because if we really want to be able to say it's holistic and interoperable, I mean, holistic and being able to reach autonomy, it needs to be an ecosystem. Uniform core components, and that's really those gray boxes on the right side. Single digital twin data ingestion management and a digital twin user interface, and that enables us to have some sort of I guess not predictability, but just comfort that, hey, once the data comes into this ingestion management layer, then we can confidently build on top of it. Scalable, which is seamless application and use case integration. the simulation, multi-domain simulation, ontology-based data, cybersecurity, and diverse data set integration. It's not. It shouldn't be just structured data. It should be unstructured data, and the modality of the data should also be considered because every use case will need something differently. So how do you build that scalability for use cases through your diverse data sets? So opportunities for innovation. I think these still remain today, a year or 2 years after we released this report. But network model management, a common digital twin framework, existing solutions integration. That's a big one because, you know, we every utility has invested so much money into some solutions. Not all of them are, should stick around, but the ones that are good, how do we bring them into the ecosystem? Because the last thing you want to hear in the utility is, just throw everything away. We're building everything from scratch. Computation. That's a big thing, right? Because decisions, if they're real time, they need to be, computation needs to matter. Even offline, uh, you know, it matters. So build it with computation in mind. Model interoperability, use case development. That's just those middle boxes that I showed you. Every vendor could be, I didn't talk about that, but every vendor essentially could contribute to a use case. Um, and then I find application development, and that's more of the core components of the digital twin versus the use case, which drives a decision. So I kind of flew through this here. I had the idea that we were late, but anyway, I think we should have some questions. Uh, Conclusion wise, we are at an inflection point. Big data will become a liability if we don't collect, store, and leverage it efficiently, effectively, in a timely manner. Combining insights from data with traditional simulation could optimize our decision-making process. Are the existing assumptions for simulation accurately reflected in reality? That's the big question, right? That's a question that we kept asking as we were writing this report. And I really don't think we are. Not because we don't want to, but just because we're limited by the resources that we have, right? And technology that we have. The industry is ripe for innovation, which is great news. And then, this is a way to summarize the digital twin one more time. Digital twin of the future is a scalable, open, modular system of systems platform. It maintains a high fidelity replica of the physical grid and the context in which it exists, its assets exist. It brings together the necessary processes, technologies, and application, and it maintains and leverages that digital replica to effectively operate, maintain, plan, design, engineer, and monitor the electric grid. And I understand that that's all of it. I'm just throwing, I just literally threw all the pieces there, maintenance, operation. But the point here is it's because it's scalable, you don't have to do it all at once. That's the message here, right? Is it's use case driven, meaning you build it over time. But by making it scalable and modular, you can enable to do that. You're able to do that. Um, all right, so that's all for me. So any questions or comments?
Thanks, Abdur. I don't know if Ravinder, you want to facilitate the Q&A or you want me to go?
Yeah, if you have any question, either you can put it in the chat or just raise your hand or directly speak to ask the question.
We have one in the chat. So David is asking, could we go into control? Probably that was where you showed the different stages of a digital twin in one of your slides.
Yeah,
With like slides. Yeah.
correct.
Yeah, it was this one. Yeah. Go ahead, please.
Control. Yeah, yeah. So the autonomous twin to me is where control comes in. Um, I think the control, right? So there's these other software suites obviously have really worked hard to, whether it's ADERMS or ADMS or whatever, there's been a lot of work done there for control, right? And so the question becomes, at some point, right? How does the twin does it because if the twin just acts as an autonomous brain, then maybe it just tells the DERMS or the ADMS to to control, right? Um, or it can just be an integrated function. I think, if you're so infused in a specific software tool today that does the control, well, you don't need to really, up and just remove everything, because there's been a lot of work to be done from that angle. So then maybe you have the digital twin as essentially the decision maker, into into the control, or the vendors that do have these softwares like DERMS and ADMS, could they separate the control mechanism from the intelligent mechanism, and then that by within itself allows them to integrate just the control portion of it into some digital twin ecosystem. I'm just thinking outside the box here. Again, I'm not saying this is the only way to do it. I'm just thinking though that it just depends on the utility and where they are from a integration perspective of existing technology.
And there is another question, I think, from Charles Broomfield. What are some specific use cases of interest to SCE?
So I think we're working through it right now. But I think in general the concepts of these digital twin components, the fundamental components, and this architecture, I think this is something that we've been looking at for a while now. I don't know if I have my colleagues here from SCE, but yeah, I think at this point in time, we're working through that. We're working through it because you have to. It's a very strategic thing, right? It's a match of what exists in the marketplace, and what are our gaps. I mean, we have so much technology today already, but thinking holistically, this is our next phase, right? Which is really moving. We are trying to get into eventually an autonomous grid. I mean, that is our goal, and so we want to use the digital twin as a tool to help us get there.
Okay.
Maybe I can go next. I have a question, Ravindra. Just FYI, after Chengli is thanking you for a great overview of the report, and I do as well. So my question is specifically about the building blocks of the digital twin. On one of the slides you had it. So here, this is the architecture. Yeah, this one. Yeah.
Hmm.
So I'm just wondering. I mean, this is a great roadmap, but I'm just wondering if you have taken any like steps towards implementing any of these components, yeah, specifically for model maintenance, network model management, and that area. If there is any experience that you can share with us, we'd be highly appreciated.
Um, so I myself, so it's a big, it's a big company, obviously, for us. So I myself haven't. I don't do. Was somebody else going to say something? Did I hear somebody else? No. Okay.
No, no.
Um, okay. So yeah. So I would say we're working in the model management. We're looking at it. We're taking some steps towards it. But the problem here is if you really sit down and think how many models you have besides electric, that's the key here is infusing them, right? And so we we have some applications where we're leveraging LiDAR for vegetation encroachment, right? And so there you're bringing together your network electric model with your LiDAR model, for example, in GIS. Within our ADMS and GMS, we're doing a lot of model management there as well. So yeah, we've definitely taken a lot of we've moved towards it. There's a lot of still data quality issues, and being able to correctly reflect what's out there, right? I think that's the big thing is because data quality and model management kind of tie in sometimes if you really look at it, and that's really the challenge. I think the challenge is being able to have the proper data quality to create better models.
Thank you.
Yeah, and there's, I mean, there's vendors that are, saying they have those capabilities. It's just a matter now of identifying which ones uh, have this vision of interoperability, right? That's the big thing. So, we're not just going to adopt, and this is again, I think any utility, if they want to take this route, realistically, because we sat down and thought hard about this, but realistically speaking, if you keep integrating solutions that are not interoperable, that use their own model of how they lay out the data, um, I think you're not going to be able to move forward. So that's the big piece is interoperability, and I think that's where the gap is.
There is another question from Charles. So, could you speak to the fidelity of data, I, for example, time scale SC currently collects on network operations?
Can you see the last portion?
So, could you speak to the fidelity of data, for example, time scale SCE currently collects on network operations?
Um, well, so fidelity, I mean, we collect PMU data. We have data that's from DFRs, that's continuous data, high point on wave data. Um, so we have fidelity all the way to down to, I believe, oh geez, now I'm trying to think what that fidelity is. But DFR data. I mean, if you we figured out a way to make DFRs an IoT box, right? And so because of that, we're able to stream data. I think 9.6 kilohertz, I believe. That's the speed besides PMU data. But those are two different types. They'll give you two different types of information. But yeah, the next generation AMI that we are trying to deploy, we are looking at extremely high sampling rates as well. So yeah, so I think we could have more for sure. But between AMI and DFRs, and then SCADA data, and then PMU data, I think that's generally the what we have today. So it allows us to have different visibility. So we have this big data already, which is exciting.
Another question is from David. Can you talk about your experience with digital twin open source framework, maturity level?
Um, Open source digital twin framework. I think so. This is to me. This is where the exploration today for us is just we don't know maybe we're missing something, right? But there's only a few vendors out there that are claiming to have open platforms. Um, we have yet to test them out. I think that's something that our team here internally is going to look into soon. So yeah, so if there are ones out there already, I think it's important for them to, I guess, reach out. Um, but yeah, I think we are. So the reason why we wrote this report is to drive more of that, right, and not closed source, closed ecosystems. Um, yeah, so I don't know if that answers the question though. I'm not sure if that answers the question. And I know there's a big EU obviously initiative. I'm sure there's people here from the EU of the Twin EU, and I think that project is starting from the fundamentals and kind of building up. But I think hopefully something comes out of that as well.
Any other questions? If no, then we would like to thank you, Abdul, for a great presentation, very informative one. And I would like to thank you all for joining us today. And with that, we conclude today's session. Thank you. Thank you all.
And sorry for joining late again.
Yeah, no problem.
All right.
Thank you.
All right.
Thank you, everyone.
Okay.